All right, today's lesson covers Earth's moon. Our learning target is to demonstrate and predict the sequence of events in the lunar cycle. So today we will look at some background information on the moon, and then tomorrow we look more at the actual phases because you're going to need all that information in order to be able to predict the sequence of events.
Dear Tim and Moby, could you please make a movie about the moon? From C3PO. The moon has fascinated humanity since the dawn of time and continues to captivate us to this day. It's Earth's only natural satellite, making one complete revolution around our planet every 27 days or so. The moon is the second brightest object in the sky, next to the sun, but the moon doesn't actually make any light of its own. The light you see is actually from the sun, reflecting off the surface of the moon. It's kind of like shining a flashlight on something in a dark room. Right. The moon doesn't always appear as a perfect circle. It goes through phases. Sunlight strikes the moon at different angles throughout its journey around the Earth. The way the moon looks to us depends on how much of the moon's illuminated side is visible to us at the time. The moon may take 27.3 days to orbit the Earth, but the time from one full moon to the next is 29.5 days, because the Earth is also moving in relation to the sun. We call this period from one full moon to the next a lunar month, by the way. Moonwatching is a fun thing to do. The moon is an average of about 380,000 kilometers from the Earth, which is pretty close when you're talking about space. Because of its proximity, you don't need a telescope to see the features on the moon's surface. The dark patches are sunken plains called seas, or maria, which is Latin for ocean. No, they're just called that. There's no liquid water on the moon, but there is some water in the form of ice. Recently, a NASA spacecraft discovered almost 100 kilograms of ice and water vapor near the moon's south pole. Yep, it's possible there's lots more buried just underneath the surface, but I wouldn't count on, a skating rink or anything like that. The lighter patches are mountains. And armed with a pair of binoculars, on a clear night you may be able to see the craters formed by ancient meteor collisions. Well, there's a lot of debate as to how the moon got there in the first place. Some scientists believe that it may have just formed along with the Earth from the initial cloud of gas and dust that formed our solar system. Another idea is that Moon was once part of the Earth and broke off for some reason. It might have just been floating through the solar system and got captured by the Earth's gravity. Still another theory suggests that a rogue planet, about the size of Mars, smashed into the Earth, creating a cloud of molten rock that eventually condensed into the moon we see today. No one really knows for sure. Regardless of how it formed, the moon is basically a ball of igneous rock with a small core of iron and sulfur. It has a rocky crust consisting of aluminum and calcium. You can find bigger moons in the solar system, but ours is the biggest compared to the size of the mother planet. It's large enough to pull at the waters of the Earth, causing tides. Still, gravity on the moon is only 1/6 of the Earth's. That's why this air conditioner feels 6 times lighter up here. And since the moon has no atmosphere, there's nothing for sound waves to travel through. That means it's absolutely silent here. On July 20th, 1969, the landing module Eagle from the Apollo 11 mission touched down on the surface of the moon. They collected some samples and then blasted off, leaving this plaque behind. Here, men from the planet Earth first set foot upon the moon. We came in peace for all mankind. The first moon landing, as far as I'm concerned, is one of the greatest moments in human history. Be quiet. I have something in my throat and my eyes.
The moon is a natural satellite. But what is a satellite? A satellite is a moon or machine that orbits a planet or star. When we look at the other planets in our solar system, we can see that the number of natural satellites varies greatly. While Mercury and Venus have none, Jupiter and Saturn have 63 and 62 respectively. The moon is about 240,000 miles from the Earth. The average distance to the moon equals about 30 Earth diameters. So that would be stacking 30 of our planet on top of each other before we reach the moon. The moon is 2,155 miles in diameter, or about 1/4 the size of Earth's diameter. So this is how big the Earth is next to the moon. So if the Earth were hollow, 50 moons would fit into the Earth. This is a photo of Earth and our moon taken from 114 million miles away. During the day, the moon's temperature can reach as high as 212 degrees Fahrenheit in the sunlight. In the nighttime, in the shadows, it can reach negative 270 degrees Fahrenheit. The moon's surface has no atmosphere, no liquid water, extreme temperatures, and it is 1/6 the Earth's gravity. The Earth's moon revolves around the Earth as both go through the space and revolve around the sun. Revolution of the moon around Earth takes about 27.3 days. The rotation of the moon on its axis is also 27.3 days. Because the rotational period is equal to the period of revolution, we always see the same side of the moon from Earth. In the next animation, we'll see how that fact is why we always see the same side of the moon. So the moon without any rotation, then we would see both sides. If the moon rotated this way, we would also see both sides. But since this isn't actually what the moon does, and the moon revolves and rotates at the same rate, we always see that red side of the moon. The moon rotates on its axis once in the same time it takes to orbit us once. So here we can see it casting the sun's shadow. The rotation period of the moon is exactly the same as its period of revolution. You can see that from Earth, you're seeing different parts. Synchronous rotation will eventually happen to the Earth too. Its rotation rate will slow down to eventually match its revolution around the sun. Here we can see the near side of the moon, the side that we always see there on the left, and then an image of the far side of the moon, the side that is never seen from Earth. So what causes the moon to appear in a series of phases? At any point in time, half of the moon is lit or illuminated by the sun and half is not lit. However, for a viewer on Earth at any given time, the moon may appear to be completely lit, completely dark, or somewhere in between. These varying appearances of the moon are known as the moon phases and have been used by humans for thousands of years to keep track of time, even before calendars were invented. It takes 29.5 days for the moon to cycle through all of its phases and return to the same starting point. This is why our current calendar system uses 30 days, or about 30 days. During a complete 29.5-day cycle of the moon phases, the moon as seen from Earth goes from being completely dark, which is called a new moon, to completely lit, which is called a full moon, and then back to a completely dark new moon again. During the first half of the cycle, a bit more of the moon facing Earth is lit each night. These are called the waxing or brightening phases of the moon. During the last half of the cycle, a bit less of the moon facing Earth is lit each night. These are called the waning or darkening phases of the moon. Each phase of the moon has been given a name. When less than a quarter of the moon facing Earth is lit, it is called a crescent moon. When about half of the moon facing Earth is lit, it is called a quarter moon. When about 3/4 of the moon facing Earth is lit, it is called a gibbous moon. The complete cycle of moon phases with their full names is shown later in the video. Note that there are 2 quarter moons, 2 crescent moons, and 2 gibbous moons, one each in the waxing side of the cycle and one in the waning side of the cycle. Note that during the waxing or brightening phases, light first appears on the right edge of the moon and moves across the entire moon face facing the Earth until a full moon is reached. Thus, any waxing phase moon is lit on the right edge and dark on the left edge. During the waning phases, a dark edge first appears on the right edge and moves across the entire moon facing Earth until a completely dark new moon is reached, completing the cycle. Waning phase moons are lit on the left edge and dark on the right edge. The moon rises about 50 minutes later each night, and each moon phase rises at a particular time. For example, a full moon rises about when the sun sets, around 6 p.m. One way to remember, we say that waxing light is on the right. Waxing light is on the right. Waning light is on the left. Doesn't sound as good. Here are our phases of the moon as seen from Earth. We start with the new moon. Then the light grows or waxes, and that light is on the right side. So we have a waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous. The light is starting to be on the left, last quarter, and the waning crescent. These positions kind of show it shows what we see from Earth and then what is actually happening. So you see the sunlight in this diagram is going to be on the right hand side, and you see that half of the moon is always lit, but we don't see that entire lit side from Earth. Same here, so the sunlight is showing from the left. You will need to be able to identify which phase is which simply by knowing the position of the moon in relation to the Earth and sun.